really cold beaker. I have one like room temperature water beaker, and I have one really hot beaker. I'm gonna put a liquid in it. So we're dealing with osmosis or diffusion? Liquid. Diffusion. So I'm gonna put a food coloring liquid drop. If I put it in the hot beaker, is this going to diffuse really fast, really slow, or just at a regular rate? Fast. What do we know about hot water or hot particles? Yeah, they expand. What else are they doing? They move really fast. So all the water particles in this water right now, they're moving really fast. So they're gonna start bumping into this food coloring, and then it's gonna be able to diffuse really quickly. So when I add the drops in, do you see how it's starting to diffuse and the whole thing's gonna turn red? The red food coloring was at a higher concentration at the top when I dropped it in, and now it wants to evenly disperse to get around the whole beaker of water. So now when I go to the really cold beaker of water, is it gonna go faster or slower than the hot? Slower, because we know that cold particles are moving slower. So I put this drop in, it's just sinking to the bottom, right? It's not spreading out as much and as quickly as the red. And then when I put it in the one that's like a room temperature, it's gonna be like right in the middle of that. So if you look at these two, do you see how this one's not dispersing? And do you see how quickly this one did it? So that's speeding up the rate of diffusion. What's another way you can speed up the rate of diffusion? If I put food coloring in it and I wanted this to be spread out evenly, what's something I can do? Stir it. That's also increasing the rate. Because then I'm physically and manually moving the particles around.